You hit spacebar or tap a red triangle, and the video starts. To you, it feels like opening a digital valve. You turn the handle, and the video flows straight to your screen. You likely imagine a simple transaction. Somewhere in a massive warehouse of servers, a video file called video.mp4 is waiting. You ask for it, the computer finds it, and it plays. It doesn't work like that. The moment your finger hits the screen, you aren't just opening a file. You are launching a millisecond-scale global operation involving subsea physics, edge architecture, real-time compute auctions, and predictive data routing. Before the first frame hits your eyes, your click travels away from your device and into a digital architecture built to make physical distance disappear. To understand where your click actually goes, you have to follow the signal down your local connection. It leaves your phone or laptop as radio waves or electrical pulses, racing through your router and down your home's copper or fiber line until it hits your internet service provider. This is level 1 of the chain. But your ISP doesn't hold the video. It only holds a query. Where is the fastest path to this content? Your request hits a domain name system server, which acts as the internet's master directory. But instead of routing your request to Google's primary corporate data centers in Oregon or Iowa, the system routes you to a location much closer to home. Google operates one of the world's largest edge networks, known as Google Global Cache. Instead of forcing your request to cross thousands of miles of transatlantic cable every time you click, Google physically installs customized racks of servers inside the facility of your local internet provider. If the video you clicked is popular, it isn't coming from a distant server farm across the country. It is sitting on a hard drive inside a server box located just a few miles from your house, in the very building that routes your neighborhood's internet traffic. Your click requested the video, but the system checked your location, your network health, and server capacity before deciding which specific physical machine within a few square miles should serve you the first slice of data. This introduces our first set of hidden players, IXPs, or Internet Exchange Points, and CDN edge nodes. They form the quiet middle layer of the internet, a dense network of physical real estate and infrastructure agreements that allow massive tech platforms to embed their hardware directly into telecom facilities worldwide. Yet, retrieving the video file is only half the chain. The moment your request arrives at the server, a second, parallel system wakes up. While the server prepares to stream the video's opening segment, it triggers a sub-second commercial machine, the ad auction. If an ad plays before your video, your click didn't just ask for content, it put your attention up for sale. In less than 200 milliseconds, an automated system runs a real-time bidding process. Information about your device type, general location, time of day, and anonymized user signals are packaged into a request and broadcast to ad exchanges. Demand-side platforms, DSPs, the hidden automated brokers acting on behalf of brands, analyze this signal instantaneously. Software algorithms evaluate how much your specific view is worth right now. Bids are submitted, a winner is chosen, and the ad code is merged into your video playback manifest before the initial video buffer even finishes filling. All of this happens before the visual display updates on your screen. As the playback begins, the video file itself isn't delivered as one long, continuous clip. Instead, it is sliced into tiny chunks, usually 2 to 6 seconds long, encoded at multiple resolution tiers, from 360p up to 4K. This is where the platform's adaptive bitrate streaming algorithm takes control. As you watch, your device is continuously measuring your connection's throughput, latency, and hardware capabilities. If your Wi-Fi dips for a fraction of a second, the server doesn't pause the video. It seamlessly shifts the next 3-second fragment down to a lower resolution, switching back up the instant the line recovers. You are not watching a static file. You are receiving a real-time, custom-assembled stream of microfiles dynamically compiled for your exact device at that exact second. Behind this delivery lie the physical engines of the modern internet: subsea fiber optic cables, hyperdense data centers, and specialized cooling infrastructure. Deep underwater, glass fibers thinner than a human hair carry pulses of laser light beneath ocean floors, stitching together global networks to ensure that if a video isn't cached locally, it can cross an ocean in a handful of milliseconds. Inside data centers, thousands of custom-built chips operate around the clock, continuously retranscoding millions of hours of video into efficient formats to minimize global bandwidth usage. Then comes the mid-video shift, the hidden realization of what your click really accomplished. You think you clicked to watch a video, but from the perspective of the system, your click was a data point fed back into a predictive recommendation engine. The moment the video begins, a continuous telemetry log opens between your app and the platform's analytical backend. Every action you take, how many seconds you watch, whether you pause, if you skip forward, if you mute the tab, or how fast you scroll past recommended titles, is logged and indexed. This data doesn't just record what you did, it shapes what the system will present to millions of other users over the next hour. Your single view alters the statistical weight of that video within a global neural network, adjusting the recommendation distribution for people thousands of miles away who share similar viewing patterns. By clicking play, you moved from being a consumer of content to an active training node in a real-time feedback loop. Consider the path of that single action. You tapped a glass screen. That micro-movement generated an electrical signal that traveled to a local router, queried a DNS directory, accessed an embedded cache server down the road, triggered a split-second ad auction across automated platforms, engaged an adaptive streaming algorithm, pulled data encoded across ocean-crossing fiber networks, and fed your immediate behavioral response back into an AI engine, managing the attention of over 2 billion people. You still see only a simple video playing on your screen, but now you know that behind that single tap, a vast digital machine moved across the world just to show you the next frame.